Lesson 3. Creating a physical standby database by using SQL and RMAN command. After completing this lesson, you should be able to configure the primary database and Oracle Net services to support the creation of a physical standby database and role transition. And we will also learn database no logging enhancement. And finally, we will create physical standby database by using duplicate target database for standby from active database command. And also, after database is created, we will see PL SQL procedure, which is a dbms underscore dbcomp. And also, we will see how to create standby database by using dbca as well. Since this lesson is quite a long lesson, I will split this lesson into 3 sections, so that way each section will be much more manageable. So I will start with preparing the primary database, and the next section will be preparing standby site, and then I will introduce other method for standby creation. So here are the steps to create a physical standby database. In the very beginning, you will have to prepare the primary database. You will prepare primary database as much as possible, so that way you can reduce amount of tasks in the standby site. And then we're going to set several parameters on the physical standby database. But actually you will set parameters in the primary database, and then we're going to create duplicate target database based out of it. So when you set certain parameters to be used in the database with a standby role in the primary database, then your standby database will take the parameters as a part of a physical standby database creation. And then your primary database will use the same parameters in case of a role transition service. In the previous lesson, we learned that Oracle Net service is very important in the data guard environment. So we will configure Oracle Net services, and we will review Oracle Net services. And then we're going to start standby database instance up to no mount state. And then we're going to execute duplicate target database for standby from active database RMAN command. Once physical standby database is ready, then we will enable redo transport service. So we will confirm whether redo can be transported successfully or not. So first step, preparing the primary database. In order to support no logging operation, it's a good idea to configure your database with a forced logging, because standby database is synchronized by applying redo. When you perform no logging operation in the primary database, then redo will not be generated, thus the standby database cannot be synchronized. So it's a good idea to enable forced logging at the database level. And also, you can create a password file to authenticate sysdba user account and other administrative user account. And also, you will have to create standby redo logs. Even though your current database role is a primary, it's a good idea to create standby redo log in the primary database, so that way your physical standby database will have standby redo logs. And also, if your primary database becomes a standby later on, we can leverage the same standby read logs. And there are a couple of parameters that we will have to set to prepare for primary database and also to support redo transition service. So very beginning, you will shut down database immediate and start up database mount state and configure your database archive log mode. That's very important because standby database, it is synchronized by applying redo. So configure your database in archive log mode first. And force logging mode. In the primary database, make sure you enable force logging so that way, even for the no logging operation, we can capture redo and redo can be applied in the physical and standby database. In the current version of a database, we have an additional logging option. So when you look at two additional logging enhancements, we have an alter database set standby no logging for data availability option. That's in addition to force logging. And we can also use alter database set standby no logging for load performance. So when you look in the first bullet, standby no logging for data availability mode causes the load operation to send the loaded data to each standby through its own standby connection. When standby no logging for load performance mode is enabled, the no logging process can stop sending the data to the standby if a network cannot keep up with the speed at which data is being loaded to the primary. So when you read this slide and first and third bullet itself, it's a little bit difficult to understand. So I will show you one handout. Okay, so here's your handout. When you look at alter database force no logging option, in the primary database, I just draw the 4 blocks. Okay, one block in red, another block in yellow, another block in green, another block in blue. So when you actually perform no logging operation in the primary database, and you enable the force logging in the primary database. In that case, every time when you make changes to these 4 blocks, redo entries are generated to describe each change. And then in the standby database, these redo entries will be applied. That's a force logging option. Now, in 18C, we have 2 more new options. In 19C, we can use it in addition. So total 3 no logging features available. 3 features available to support no logging operations. The difference is when you alter database set standby no logging for option in the primary database, you're gonna perform no logging operations. Now, rather than capturing each change through redo entries with these 2 new options, Oracle will identify non-logged block image. So rather than generating 1,000 redo entries to describe changes to 4 blocks, we can simply identify 4 non-logged blocks and then ship it over to standby database. In the standby database, we apply these 4 non-logged blocks instead of redo entries. So you can guess what is the benefit of this. The major difference between for data availability and for load performance is for data availability is a synchronous non-logged block shipping. So when you commit in the primary database for non-logged no logging transactions until those blocks transported to standby database successfully. Primary database must wait. So synchronization is important, the requirement with the first command. However, for load performance, that's asynchronous mode. So performance is more important. Soon as you commit, no logging transaction, and commit complete message returned back. So we don't wait for non-logged block shipping to standby database. We continuously transport non-logged blocks. So as you can see, major difference with the force logging, every single change is captured as a read entry. With the two new options, we capture non-logged blocks instead of read entries. These are the two different changes. So I'm going to come back to slide now. Okay, so I come back to the slide. So let's talk about configuring standby read logs. The primary purpose of a standby read logs, it is to keep read coming from source database in the data guard environment primary database. Even though your primary database doesn't use standby read logs because database role is a primary, but in preparation of a physical standby database creation and also in preparation for role transition service, it's a good idea to create standby read logs ahead of time. Now, when you create standby read logs, there are two basic recommendations. Number one, size of a standby read logs should be same as size of an online read log file. So size of a standby read log file should be same as size of an online read file. And number of groups, it's a good idea to have one additional group more than the number of online read groups. And that is recommendation, two recommendations. So in a standby read log, it is to retain read coming from primary database. So that way, read apply service can read a read from standby read logs and to recover standby database. Okay, and also if a standby read logs full, then that will be archived to archive log destination. Okay, this is the way to create a standby log file in the primary database to assist the role change and also to support creation of physical standby database. We can create standby log file in the file system. And also, if this were a rack database, real application cluster, you will have to create log file in the shared file system. In our case, data ASM disk group. So first command, alter database, add a standby log file. And on the user one mount point, we have one standby log file created. Each size is 50 megabytes. Assumption is your online redo size is 50 megabytes. This 50 megabytes is just an example. In your environment, you will have to size online redo, thus also standby redo based on your checkpoint interval. So it's a good idea to keep about 10 to 15 minutes worth of redo changes, redo entries in the online redo log file. Okay, so we can also view standby redo log information from $log file. When you filter log file by type standby, it will show you current existing standby the log files. And also you can see the $standby log to see current status. As you can see, all unassigned except for the first one that was created. But these are all not in use until your primary database becomes a standby database. Okay, so we also set init parameters on the primary database to control redo transport service. You will have to set log archive config, and this parameter is used to configure DataGuard configuration. So it enables sending and receiving of redo. And we also set log archive dest to control redo transport service. We're going to see example. And also log archive dest state. So what is state of log archive dest? You can enable, you can disable, you can defer you can make destination as a deferred destination as well. And also we have archive leg target. Force a switch after specify the number of a second. In the idle time period, like at night, if there is no transactions going on, we can actually force to switch log file at any given interval. So that's one possible parameter setting. And also a log archive trace, it controls output generated by archiver process. This is an example of a setting, log archive config. You will have to update this parameter to define DataGuard configuration. In our practice environment, we have a Boston far sync, London 2, London far sync. As a preparation of a DataGuard setup, even though you may create only few of a component, you will have to list all of a component. So that way we can enable and disable redo sending, redo receiving of these components. And log archive dest. This log archive dest, the first parameter, the log archive dest 1, it is to define local archive destination. Whenever online redo log file is full, and the online redo will be archived to the local archive destination. But from second destination, log archive dest 2, we define remote redo the local remote archive log destination. So which could be far sync instance, which we're going to discuss later on, and also physical or logical standby database. So in the DataGuard environment, especially primary database, at least you will have to have location setting with a log archive dest and service setting for log archive dest. One for the primary database archive log file, and the other one is to ship the redo to physical or logical standby database or far sync instance. So example in the last bullet, log archive dest 2. Now this location is a London location. So your primary database uses log archive dest to transport redo to location where London net service name is defined, and also London the net service name defines. So we also have a valid for this destination is valid if a current database is a primary database, and also online log file is in use. And also DB unique name is London, and this state is enabled. So this itself, it is to define the remote archive log destination. When you configure log archive dest, it's a good idea to add valid for attribute of init parameter. Now valid for is very useful to support role-based destination. Now, this destination is only valid when condition is met. For example, you are in the primary database right now. In the primary database, you have a log archive dest2, and this is to transfer redo to London database asynchronously. And this destination is valid if a current database, which is your current database, is a primary, and also online log file is in use. So primary database transfer redo to standby database. However, in your standby database, you may have a same setting, log archive dest_2. It is to transfer redo to Boston asynchronously, but this destination is valid only when the current database is a primary. Boom, no. Your standby database, okay, your database role is a standby. So this destination will not be used until the standby database becomes primary. So we can define remote log archive destination ahead of a time, so that way we can simplify the maintenance work and operational work. So this is to support role transition service and simplify your redo shipping configuration. So this is a reference. It gives you, valid combinations for valid for attribute, and also certain settings and combos ignored. For example, we have a standby log file and standby role. If your database is a primary, definitely it is ignored. So we have a physical standby and logical standby database. So this setting will be used by physical standby and logical standby database. But what about this? You have an online log file primary role. The primary database has only primary database role, and online log file is in use, so this will be valid. But what about this? Online log file standby role. The logical standby database, its database role is a standby role. But logical standby database has its own online log file as well. So this combination only valid for logical standby database. So as you can see, we have different combinations, and depending on your database role, certain combos are valid, but the other combos not valid. So you have to review this. When you configure log archive dest, you can also specify how you want to ship a redo to standby database or far sync. We have a sync or async option. So what's the difference between sync and async? And also we have affirm and no affirm. So what's the difference between affirm and no affirm? I'm going to show you whiteboard work to explain sync and async and affirm and no affirm. Okay, so let's take a look at a very simple data guard configuration. Suppose that you have a primary database, and this primary database name is a Boston database. And also we have a standby database, and standby database name is a London database. And we enable the redo transport service. So redo is transported from Boston to London database. And also in the Boston database, we have online redo log files. So we have online redo here. In the standby database, we have a standby log file. As we know, every time when you make insert, update, delete from primary database, redo is generated, and redo is written to online redo log file. It's by log writer. So log writer is responsible to write redo to online redo log file. I will use a short name, online redo log. And also, the other side, standby database, it has a standby redo log file. So log writer continuously write redo here. And also, primary database, it transfer redo to standby database. Let's see here, when you issue commit for transaction. So when you issue commit, when does Oracle complete commit statement? That's depending on your redo transport mode. For example, if you configure a remote archive log destination with a synchronous redo mode, when you issue commit statement, your commit is complete until only when the reader for committed transaction is transported to London database and receive acknowledgement, then commit statement can complete. So synchronous, this is a synchronous commit in the data guard environment. So your commit statement wait until reader for committed transaction synchronously transported to London database and then receive a successful delivery message at the Boston database, then we can complete commit statement. So there is some round trip time, but it gives you a zero data loss, zero data loss in a configuration feature, because at any given point, your standby database is synchronized with respect to commitment, and that's the idea. Now, this is the synchronous commit over the network in the data guard environment. But there's one more thing. In addition to sending redo to London database synchronously, we can also wait until redo transported to standby database is written to standby redo log file. So that is a firm option. So, we have a synchronous redo shipping to transfer redo for committed transactions synchronously and wait until the received redo is written to standby log file. So that's sync and affirm. Sync is through the network. Affirm is for disk I/O, synchronous I/O. And this will be slow, but it guarantees zero data loss. Now the other possible option is we have async option. Async option is this. Soon as the redo for committed transaction is written to online redo log file, then we complete commit statement without waiting for successful redo shipping to London database, successful I/O to standby redo log file. So that's why it is faster. However, you may lose data or sub-second worth of data or second worth of data in case of a failover. Because even though you have a redo for committed transaction written to online redo log file that's not available in the standby database, but for that moment, if you have a site failure, you lose that amount of data. So depending on the distance between primary and standby database, and also your transaction rate in the primary database, you can choose synchronous read transfer service or asynchronous read transfer service. That's your choice. So let's come back to slide. Okay, so I came back to slide. So I briefly introduced the attribute of a log archive dest, synchronous read transfer service, asynchronous read transfer service, and affirm and no affirm option. Synchronous read transfer service, it works with affirm. Asynchronous read transfer service, it works with no affirm. Okay, so let's take a look at other init parameter settings on the primary database to support role transition service. So we will discuss about db file name convert. We will discuss about log file name convert. We will discuss about standby file management, and we will also discuss about Failover. Okay, first one is db file name convert. Your standby database directory structure may not be same as a primary database. So in the standby database, you will have to set db file name convert to map your source data file structure to the standby database structure. For example, user 1 Boston to user 1 London, and also user 2 Boston and user 2 London. It's a mapping. Okay, and also we have a log file name convert. So for the online redo and also standby redo, we have to map. So we have a redo coming from user 1 Boston logs, and then must be written to user 1 London logs. So you will have to map a log file as well. And this parameter only works in the physical standby database. If you have a log file name setting, convert setting in the primary database, and that's only to support role transition service. But this parameter and previous parameter works in the physical standby database side. And also we have a standby file management. So in this case, this parameter works only in the physical standby database, but you can set it on the primary database as well for role transition service. Standby file management is simplify data file creation and data file deletion. For example, when you create one data file in the primary database, then the same file will be automatically created in the standby database. When you delete a data file, that will be cascaded in the standby database. That's automated. However, there are cases where files must be managed manually, and that topic will be covered in next lesson. So that's one simple setting. It's a good idea to set it to auto when you create physical standby database or in preparation of a physical standby database creation. And we also have a Failover. The Failover is used to specify the name of a fetch archive log server, usually primary database. It's used only by databases in the standby role, and it is created on both primary and standby database for role transition service. So fail server setting here, Boston, FarSync, and London, or in the London database, we can set it to Boston, FarSync, and Boston as well. Let me give you a whiteboard note to explain fail server a little bit, and I will come back to slide. So let's take a look at whiteboard here. So suppose that we had a network issue, so we lost the network, or we have a network outage for a certain amount of time. In the primary database, we continuously commit and update. So we have a commit system change number 100, 101, 102, 103. It is increasing. In the physical standby database, we received and applied the changes up through 99. So from 100 to 103, these are the missing redo entries. Now later on, when the network is recovered, your physical standby database, in this example, it can detect missing redo, especially it's by MRP background process, media recovery process, or redo apply service. Now, when it is receiving the first available redo, let's say 104, and this 104 will be scanned by MRP, and MRP will check last applied redo, which was 99. So we have a gap. So what MRP does, it will request missing redo by communicating with the primary database. So MRP process, it will use fail server, and then we can set it to Boston, which is my primary database. So what it does is, because it's a background process in the London database, it cannot make foreground process connection to Boston database. MRP process, it uses fail server init parameter and then spawn fail foreground process. Okay, I have a net service name using fail server to connect to Boston database. And if this fail server, it will work with the archival process and request missing redo. Okay, so we found missing redo, and why don't you transport all missing redos to resolve a redo gap automatically. So this fail server will contact archiver to transport missing redo. For this matter, we have to set this parameter. What if you haven't set this parameter? Then what? Then MRP cannot request missing redo. Okay, this should be done by the other component. Okay, so in order to let MRP directly work with a primary database, we will have to set this parameter. So that is a small whiteboard work. Let me come back to slide. Okay, so I came back to the slide. So that is specifying value for fail server. Now what I'm gonna do, based on this discussion, I will show you short demonstration. So I'm gonna bring up my demo environment, and I will give you short demo. Okay, so I'm in the demo environment right now. I'm gonna show you a couple of things. So I will, I already have a data guard environment. So I will log in as a sysdba. Let me show you how I configure the data guard environment. I already have a physical standby database in the demo environment. So in order to create data guard, the primary database and standby database in the data guard environment, show parameter I updated log archive config. So as you can see, I have a Boston file sync, London file sync, London too. So my demo environment is the same as your practice environment. Eventually, you will have to configure exactly the same way. And also, I have local archive destination. So I use a faster recovery area as a local archive destination. So that's why when you look at log archive dest1, it shows location equals to huge DB recovery file dest. So huge faster recovery area. And I also have a remote log archive destination. So show parameter log archive dest underscore 2. As you can see, I have a Boston file sync. When you do practice activity, you will initially configure log archive dest 2 to transport redo to London database, physical standby database. In my case, I added an additional component in between, which called the file sync. We didn't discuss this topic yet. And also, in my physical standby database, so this is my physical standby database, which is a London database. And in this environment, I have a show parameter db file name convert. As you can see, I have a db file name convert. Boston is mapped to London. For your information, when you create primary database using DBCA, either silent mode or GUI mode, you have to double check directory path. When you create primary database in the directory file system, the local file system, you will see that your SID directory it will appear in uppercase. So if you have to make sure directory name whether it is a lowercase or uppercase. I think that has changed starting from 18C. 18C DBCA, it automatically converts your DB unit name in lowercase to uppercase in the directory structure. So I had to use uppercase in this case. And also, I have a show parameter DB. Actually, we have a log file name convert. So I have an online read log file under U01 app Oracle Oradata Boston uppercase, same region. And my standby log file is located under U01 app Oracle Oradata London uppercase. So that's what you have to check. And also, we have show parameter standby file management. As you can see, it is auto. So when you create one table space data file in the primary database, and your file created in the primary automatically created in the standby. But there are certain cases where user intervention is needed when you make any changes in the primary database. So standby file management itself may not work to automate creation of a file in the standby database, and that will be covered in lesson 4. And also, we saw in a file server, so show parameter file server one more time here. So we have a file server setting here. This is a quick demonstration. So in this lesson, we learned how to prepare the primary database, and I went through all the steps, and also I gave you a short demonstration as well. Okay, so now let's get into the second part of lesson 3. The second part is more focused on preparing standby site. Before getting to standby site preparation, let's review initialization parameters on the primary database. We stopped at this point. So as you can see, we discussed about log archive config, and also we discussed about log archive dest, and also you can control how to transport redo to standby database asynchronously or synchronously, and also you can make log archive dest valid based on valid for attribute of this parameter. And then also we discussed about file server and standby file management and DB file name convert and log file name convert. So these are all the topics. Now, in the physical standby database site or logical standby database site, you will have to prepare for standby database creation. Creating an Oracle Net Service name on the primary for your physical standby database. So it's a little bit more additional option. In the primary database, make sure you have a Net Service name to connect to a standby database that will be created on host 03. On the standby database, you will have to register service with a static service registration. So your standby database, your primary database can connect to standby database initially in no mount state, and after a standby database is created, the primary database must control the standby database. So if you are using RMAN, RMAN restart standby database remotely. To start remote startup of a database, we will have to register service with a static service registration. That's what I showed you as a part of a demonstration. And also, you will have to copy password file from primary database to standby database host. And also you have to rename it ORAPWSID. Once password file is copied over to standby host, and you start up your standby database and you create standby database, from that point, any changes to password file can be captured and propagated to standby and apply to recover password file in the standby host. So that's in a feature currently available. But there is another thing what we have to know. In the later lesson, I will cover password file management, but not in this lesson in detail. And we will also have to create a P file, init file. We will actually add enough information to bring your physical standby database up to no mount state. Anyway, this init file will be replaced with the SP file as a part of a physical standby database creation. And then we're going to create required directories, a dump directory, your physical standby database location, and PDB seed for container database example, dep1 for another plug of a database location, and also faster recovery area. In our environment, London is uppercase, even though DB unique name is London in lowercase. Directory structure includes uppercase London, just for your example, for your information. And also, the primary database is a multi-tenant database. Thus, your standby database is also multi-tenant database. To support multi-tenant database, you have to create database directory structures accordingly. Finally, we start a database instance of the no mount state by using temporary init file. Now you're going to prepare RMAN script to create physical standby database. You allocate channel to primary database. You allocate channel to physical standby database instance that is currently in no mount state. And then you're going to run duplicate target database for standby from active database. As a part of executing this script, SP file is copied over and SP file content will be updated. So in this case, parameter value convert Boston, London, London, Boston, London. So you have to update SP file content accordingly. So finally, we connect to target database, which is a primary database. We're going to connect to auxiliary database. And then we're going to execute this script. After you create physical standby database, when you look at redo apply service, Oracle will use real-time apply feature, meaning that MRP, redo apply service background process, it will apply changes, redo in the standby redo log file and directly apply it to standby database. So redo in the standby redo log file is scanned and then they will be applied by MRP process. If you want to control the starting up of a redo apply service, you're going to run alter database recover manage the standby database disconnect. If you want to stop, then alter database recover manage the standby database cancel. If you want to disable real-time redo apply, then you have to use alter database recover manage the standby database using archived log file disconnect, meaning that we wait until standby log file is archived and then redo in the archive log file to synchronize, to recover physical standby database. So we can actually control redo apply service status and each mode by using SQL command. And later on, when we discuss about Data Guard Broker and Enterprise Manager, you will see another interface for the same purpose. And also, we can set up init parameter to detect data block corruption and also redo corruption. So we can use DB lost write protect init parameter to implement lost write detection, either right before redo transfer service or right before redo apply service. The redo will be validated to see if there is any missing data, missing redo or lost write. Another way to detect lost write without setting this init parameter is using dbms db compare package. So this allows us to compare data files to check lost write and inconsistency between primary database and physical standby database. During the comparison, we're going to use $v session long ops to see the progress of a block comparison operation. So we can use this DBMS package for different use cases. For example, if a primary database, let's say primary database is Boston, and all standbys, let's say your standby database name is London and Chicago. If these databases are mounted or open, and you execute dbms db compare from primary database, then data file will be compared between primary and every physical standby database. So you will have one report that give you comparison between primary and London standby database, and another report that give you primary database and Chicago-London database comparison. And another case is if a primary database and all standby databases are mounted or open, but you execute DBMS compare from standby database. If that is the case, the specified file will be compared between primary and only that particular standby that issued the DBMS package. And you will have a comparison report. Primary database is mounted or open, but not all standbys are, and DBMS compare is executed from the primary. So if that is the case, data files compared between primary and mounted or open physical standby database. If a standby database is dismounted or shut down state, then there will be no report. And if a primary database is mounted or open, but not all standbys are, and DBMS the package is executed from standby, then the specified data files are compared between primary and standby from which DBMS compare is executed. It's the same as in a previous case number 2, I guess. And the primary database is not mounted, but multiple standbys are mounted or open. Because the standby is not mounted or open, DBMS cannot find the pair of a primary and physical standby to compare. If a primary database mounted or open, but no standbys are, because no appropriate primary database and physical standbys pair is found, the message is printed in the output file, no ORA error is returned. So in this case number 5 and 6, there is no target to compare, so you will not get actual comparison report. So just like in init parameter, you can also use a DBMS DB compare package to compare files between primary and standby databases. Okay, so now I'm going to show you short demonstration about the second section. So I will open up my demo environment and I will show you a couple of things. Okay, so I'm in my demo environment. Let's take a look at a couple of things. So in my physical standby database location, I already have a standby database. So I'm just check a few things. When you look at Oracle Home DBS directory, as you can see, I already have a password file for London database. As a part of a practice activity, you will have to copy this password file and you have to rename it for physical standby database. And also, when I set up this demo environment, I created a P file, and in the P file that will be used to create physical standby database, we only need 2 init parameters. One is a DB name and the other one is a DB domain. These parameters are enough to support initial the status of the physical standby database. And later on, this file, this P file will be ignored because SP file will be created. And also, let me show you directory structure. For this demo environment, I created this primary database, Boston database using DBCA. When you look at directory path, as you can see, Boston is uppercase. And when you look at standby database, I already created it. London is also uppercase. Because of this region, I had to update db file name convert uppercase Boston, uppercase London. So that's what I had to change it. Okay, so that's one thing. One other thing what you have to know. And also, so let's take a look at one other thing. And during the practice time, you will execute a couple of scripts. Especially, I created this script. I have a create underscore London RMAN script. So as you can see, I have a channel allocation to primary database, channel allocation to physical standby database, and there are some of init parameters with the lowercase Boston, lowercase the London. But there are also parameters that takes uppercase as well, so I added 2 pairs. And also db file name convert. So because data file directory structure include uppercase Boston, I had to map to uppercase Boston and London. Same thing for log file name convert as well. So you can execute this script as a part of a practice activity. So that's what you're gonna see. And also, since I created a physical standby database, in my environment, I should be able to see redo apply service. That's the MRP background process. But when you log in as a sysdba, you can also stop it. So alter database, recover, manage it, standby, database, cancel. So when you cancel it, MRP process will be stopped. So it's gone. If you want to restart, alter database, recover, manage it, standby, database, disconnect. By doing so, I can restart MRP background process. So pgrep -lf MRP, it comes up again. This is a short demonstration. So far, we covered how to prepare primary database. In this section 2, I mainly focused on preparing standby site. Let's start section 3 of lesson 3. Section 3 is to discuss other methods for standby creation. In the previous sections, we focused on creation of a physical standby database using SQL statement and RMAN utility. But there are also other options as well. For example, we can use an enterprise manager to create physical standby database and also other types of standby databases. The thing what you can do is when you get into enterprise manager database page, under availability menu, and there is an option called add standby database. From this option, you can choose the creation of a physical standby database. You can create new physical standby database, and also you can create new logical standby database, and you can register existing standby database with a data guard broker, and also create primary database backup only. So if you want to create physical standby database, you choose the first option to create new physical standby database. Now there's another option. You can create the standby database by using DBCA. So we can use the DBCA option with the create duplicate DB. That's the option. And then you can actually add an additional option to create standby database. So here we have option -create as a standby database. So DBCA silent mode, create duplicate database, and you provide the duplicate target database name and also primary database connection and SID, and create standby database and standby database specification. This DBCA method, it only supports non-CDB database. So if your primary database is a CDB database, then you cannot use this option. However, if your primary database is a non-CDB, then you can choose this option to create non-CDB standby database. Here's an example. Suppose that Boston database is a primary non-CDB database, and London is the non-CDB standby database, and we have a domain example.com. So to create London database, use DBCA-silent create duplicate DB and global database name london.example.com, and primary connection is host01 boston.example.com, and SID of a physical standby database will be London, and DB unique name will be London, and then we create as a standby database. So we connect to Boston database, we connect to London database, that is in no mount state, and then we're going to initiate DBCA silent mode to create non-CDB standby database. So that is another option that you can use to create physical standby database. And also, without using RMAN, without using DBCA, you can do everything manual by using SQL statement. That's actually the old method and manual method. So you can create backup copy of a primary database files. You create control file for the standby database from primary database. So alter database, create standby control file. And then you're going to create parameter file from the server parameter file used by the primary database, and then adjust the parameter and transfer complete backup, standby control file, and parameter file to the standby system, and then create SP file and startup database, no mount state, and then restore backup, and then the start read transport service and read apply service. So all these are the manual, the process. So you can use RMAN, you can use Enterprise Manager, you can use DBCA, and you can also use SQL command to create standby database. Okay, so let's take a look at the next page. Standby database on the same system where primary database is running. It is supported, however, it doesn't protect your database against the disaster. It's only for testing purpose, so to see how you can create physical standby database. So if you want to practice the whole process, yes, you can create standby database on the same system, but not for the disaster recovery solution. And we have a quiz here. The forced logging mode is required to support the unlogged operation in a data guard environment. The answer is no. But it is a strong recommendation. And also, in 19C, we have two more options. Okay, instead of enabling forced logging at the database level, you can use enhanced the option to support unlocked operation. But this is not required, recommended option. And which method support the creation of a standby database in a multi-tenant environment? We can use Enterprise Manager. We can use a duplicate database. However, DBCA is only to support non-CDB database. Now I'm going to show you short demonstration. Okay, so I brought up my demo environment. I'm going to show you how to create physical standby database using Enterprise Manager. When you go to database, primary database availability menu, and there is an add standby database option, and then you can actually click log in, and then after you wait, you will see this menu, add standby database. So let's make this a little bigger. So here we have options, create new physical standby database, and then we have other options. When you click the create new physical standby database option and you move on to next page, you have a backup type. DataGuard uses Oracle RMAN to create standby database from a new or existing backup of the primary database. You can choose a recovery manager to copy data files, or you can use existing backup. Just like creating physical standby database from active DataGuard, active database, you can choose an online backup option. And then you can specify degree of parallelism and also primary host credentials. In your practice environment, in my demo environment, software is owned by Oracle OS account, so I can choose Oracle. And then you can provide instance name, so standby database instance name. So I can provide a name like Chicago. And then you can specify database storage and also host. I will just choose random location. So let's say I'm going to choose host 03, for example. And also standby host credentials that also you have to provide. And then we have a standby database file location. So we can use OFA, Oracle Optimal Flexible Architecture Compliant Directory Structure, or keep file name and location same as the primary, and also which listener you want to use and which port number you want to use. And also standby database file location, you can customize as well. If you want to change the location, yes, you can change it. And also in the next page, we have a file already exists and will be overwritten. So it's about actually just warning we can easily ignore. And then what is the database unique name? I can provide a Chicago. And also target name. So it is a name to be used within Enterprise Manager target name. And then you specify faster recovery area size. And also you provide more information. Okay, this one I'm fine. Finally, you're going to review your setting, and then finally you click finish. So we have a Boston database as a primary, and you want to create the Chicago database. As you can see, DB name is the same because DB underscore name is shared between primary and physical standby database. However, DB unique name is different. So as you can see here, DB unique name is Chicago. So that's the database unique name. So after you confirm this, you can simply click finish. And then Enterprise Manager will perform the rest of the tasks. Okay. So since it is a demonstration purpose, I'm not going to do this. So I will simply cancel it. Okay, practice 3-1, and we will see how to prepare the primary database to support data guard. The first task is, if you already have a terminal window open on host 01, so you're going to use it. If you don't have it, then you can just open new terminal window and SSH host 01, and then you will have to set environment variable. In host 01, you will have to set Oracle seed with Boston. But since I already have it, I will close this terminal window. So assuming that you already set environment variables, so you can log in as a sysdba. And by default, your forced logging is not enabled. So as you can see from vdata database, forced logging value is no. Meaning that if you run any operations in the primary database with a no logging option, that will not be captured. So standby database doesn't know what changes made it to a primary database. So your standby database cannot be synchronized. So in the data guard environment, it is a strong recommendation to configure your database with a forced logging. So I'm going to alter database to use forced logging. And I will double check forced logging in this database. As you can see, we configure the database to use a forced logging. So now we're going to move on to the next page. We currently have 3 online reader groups. As a best practice, it's a good idea to add one more group for standby logo files. And size of each online reader logo file is 200 megabytes in size. So when you create standby logo file, you will have to make sure the size is the same, and you add one more group. You can execute alter database add a standby logo file command, but in order to save time, you can simply run a script. So it's going to create 4 standby logo files in 4 standby logo groups. And then you're going to verify. So as you can see, we added a group number 4 and group number 5 and group number 6 and 7. Even though current database is a primary database, to support or to prepare for role transition service, you add additional log groups in the primary database. So that way, when the roles are role is changed, your primary database becomes a standby. At that point, standby logo files are used. And also, when you create standby database by taking backup or by creating online backup of a primary database, you don't have to create standby logo files manually in the standby database. So it simplifies your creation of a standby database as well. This is the reason why we create standby logo files in the primary database. And then what we're going to do, we're going to configure local archive destination. So every time logo file switches, primary database, archive, online redo to faster recovery area for Boston database. So this is a log archive dest 1. In order to get rid of a spacing issue, I just created a script so you can simply execute it. Okay, so this is done. And we can also start the number of archival processes in case of a network delay or network failure. in order to resolve redo gap, multiple archivers can transport redo to standby database. So we can actually set this value. By default is a 4. According to documentation, you can set it to 10, but in our environment, the default value is enough. Even though default value is a 4, I will just execute it, just demonstration purpose. And then we're gonna define data guard configuration. So what are the members of a data guard configuration? Currently we have a Boston database, but eventually we will have a Boston file sync in the second host, London and London 2 in the third host, London file sync in the fourth node. So I will just execute this. In this practice environment, we're going to have all these members in the data guard configuration. And also, we're going to set a standby file management auto. The purpose of this parameter is to automate creation of a file in the standby database when you create new file, when you drop existing file from the primary database. Your current database is a primary, but to prepare for role transition service, we're going to set standby file management equals to auto. But this parameter will not be used in the current database role in the Boston database. Okay, that's it. So this is a practice 3-1. We prepared primary database to support data guard environment. This is a practice 3-1. Okay, so let's start practice 3-2. Practice 3-2 is to create physical standby database. Before creating physical standby database, we're going to prepare host 03 first. You locate terminal window on host 03 and make sure you set environment variable correctly. And let's take a look at the content of a script. And this script will be used to create the required directories for this host to run London physical standby database. So as you can see, we have a directory for OD file, directory for data files, and directory for PDBs, and also a fast recovery area. Depending on how you create your standby database or how you created a primary database, you will have to make sure you create directories correctly. For example, starting with the Oracle version 18c, when you create primary database using DVCA, it automatically uses DB unique name in uppercase. So when you match primary database and standby database, so you will have to check the primary database directory path and also standby database directory path. Uppercase, uppercase, lowercase, lowercase. So you have to match. Otherwise, you have to set environment of the init parameter to map from source to destination. I'm going to execute this script to create these directories. And the other one, what we're going to do, we're going to use home Oracle setup create init.sh script. It's nothing more than creating dummy init file. And eventually we're going to replace it with the SP file. So I'm going to cat home Oracle setup, create init.sh. DB name is London, but eventually this will be replaced with Boston. And domain name is example.com. So I'm going to execute this. Since I created a init file, I can use it to open London physical standby database up to no mount state. But before that, we will have to create password file for standby database. So we will copy password file from primary database and send it over to standby database. And to make it simple, you simply execute script because it's nothing more than scopy. So I copied ORAPW Boston, and it is renamed it to London. So let me actually take a look at this. So as you can see here, we copy ORAPW Boston to create ORAPW London. So now finally we're going to start London database with the P file that we created. SQL plus Azure sysdba and start up no mount. Since there is no SP file, we're going to pick up P file. Okay, so I'm going to exit out. In this environment, we also have RMAN script prepared. So let's take a look at RMAN script. Okay, so we're going to use duplicate target database for standby from active database. And also we have a parameter value mapping, Boston, London, and Boston uppercase, London lowercase. We have to change the DB name. It was London in the P file. We're going to replace it with Boston. And DB unit name must be London. And also, all your data file location must be mapped from Oradata Boston to Oradata London. Same thing for log files. So once you review this RMAN script, then we're gonna make connection. So what we will have to do is we have to make connection to primary database, which is the Boston database. RMAN target sys rock underscore for you at Boston. And we will have to make connection to the London database instance in the no mount mode right now. So we use auxiliary keyword and sys rock underscore for you at London. And we will have to use CMD file to specify RMAN script. Its path is home Oracle setup create underscore London RMAN. No, I made a typo. So in order to get rid of a typo, let me see what is typo. Okay, here I made a typo here. AUX. So we made a connection. Let me take a look at this first. We made a connection to Boston and we made a connection to London, and it goes through several things. It takes a few minutes. So instead of actually the recording, the progress of RMAN duplicate the command, I better pause this recording at this point. Meanwhile, you can just review the output that is captured in your ekit. So I will come back once everything is done. Okay, so I waited less than 3 minutes, and finally everything is done. So RMAN duplicate database command was complete successfully. So practice 3-2, it showed how to prepare host to create physical standby database. In next practice, we will see how to enable redo transport service, how to verify. This is a practice 3-2. Okay, practice 3-3, starting redo transport service and verifying operation. In the practice 3-2, we successfully created London physical standby database. Now, in this practice, we will configure redo transport service to transport redo from Boston database to London database that is running out of host 03. So in order to start practice activity, we will have to locate terminal window that is open in host 01. So assuming that you are in the OS prompt and you successfully configured your environment variables using ORA env script, and then you're going to log in as a sysdba, and then you will have to set log archive dest from the Boston database, which is the primary database. Log archive dest 1 was a local archive destination. Log archive dest 2 is a remote log archive destination to transport redo to the final destination. In this example, London will be the redo destination, which is a physical standby database. So I'm going to execute script to set log archive dest. This script is to avoid the spacing issue and typo issue, so that way you can save time. Now we're going to determine the last sequence number archived on the primary database. So 21 is the last one. So I'm going to locate host 03. Make sure you set environment variable correctly if you closed your terminal window previously. And then I will log in as a sysdba. And then you're going to double check. So now 21. So it's the same as the primary database. Now this time, we're going to switch log file from primary database. Alter system, switch log file. And definitely next sequence number is 22. And let's see it was transported to standby database. Here we go. So we received it in the standby database. So practice 3-3 is showed how to enable redo transport service to physical standby database and how to verify redo shipping. And that's practice 3-3.